So today we'll take a new topic related to applications of SDM in water resource management or land degradation. So we'll take today a new topic. Can you see the screen?
Yes, sir.
So today we'll take a new topic where whatever understanding that we are getting in digital image processing and spatial data monitoring will be applying that, because finally whatever modeling that we are doing must be applied to some natural resources. So today's example is land degradation. So first, there are a lot of discussion going on, lot of research paper is being published in land degradation, and we are situated in a desertic terrain. We are situated in Rajasthan, so there are a lot of land degradation activities continuously being done by anthropogenic activities or by natural processes. So we must first know what is land degradation, what is type, what are the factors, and how, what are the categories, and how we'll be identifying those land degradation categories on a satellite image, and finally the modeling. So land degradation is the reduction of or loss of, either it can be reduction or either that is a loss of biological or economical productivity. Either it can be flora and fauna or it can be economical, because if the land is being degraded, the quality will degrade, the production will decrease. So at last that is related to the economic productivity and complexity of land and complex problem that occurs on the land from various factors. The factors can be various, either that is climatic variation or human activity. So loss of, so what the things that you have to keep in mind? The things that you have to keep in mind is you have to check for biological, second is economical, third is complexity. Either it can be from climatic variation or it can be from human activities. So desertation means, so there is another term that is classified that is known as desertification. Means deserts. We are situated in a desert. So what does desert mean? What does desertification means? So what does desertification means? Desertification means land degradation. Means land degradation means the land is totally unproductive, totally uneconomical in arid, semi-arid, or dry humid areas. So desertification was defined by UNEP program in 1992 and adopted by United Nations Convention to combat uh, desertification in 1994. So what does it says? It says vulnerability to desertification and severity of this impacts are governed by climate. So you can see the changing climate. Each and everyone nowadays talks about on environmental day or any resource day or earth day. We talk about climate change. Climate change. So climate change is indirectly related or directly related to land desertification, land degradation, seasonal variation in weathers, because you will have a change in climatic conditions, so you will have a variations in the climatic conditions. You must be noticing it throughout the India, especially where you are located in. You will be having someday you will be having excessive rain and somewhere you are not having any rain. So that is the variations in the weather each and every day. Nowadays you're facing that your India territory is facing various kinds of cyclones. So that is also kind of climatic change. Then soil structure and texture, the pattern, because the climate is changing, the weather pattern is changing. So the soil type, texture, structures are changing. Topography is changing and vegetation type too, because according to the moisture content, according to the flora and fauna, the vegetation types depends on. So extension or intensification of desert condition involves decline in the productivity of land. So what does land degradation, if it is going on increasing, what it will do? It will convert your productive land into a unproductive land. So what is our prime responsibility? To protect our productive land for or from being converted to a land degraded category. Getting it?
Yes, sir.
So, what does India and its role? What is related to land desertification? India is a signatory to the United Nations Convention for Combating Desertification. So, UNCC, you have already known the United Nations Convention on Climate Change. That is a regular process that the topmost scientists of the world come together, express their thoughts, their findings, their research, and what are the mitigation measures that can be taken to stop or to increase this change in the climatic condition, because that is leading to sea level rising. If there will be a sea level rising, glacier of melting will be there. Glacier of melting, you will have increase in sea levels, and many of the areas which are stationed and the countries along the sea will be submerged in water. So you have to take this matter very seriously, as well as your this increase in population is there. A lot of population is going on, and if you are not protecting your productive land, your gradually the land will be converted into unproductive land, and that will create a scarcity situation of food demands in any country, and that will lead to various kinds of fights among the country, decline in weather. So you need a policy, you need uh, what measures, you need some guidelines so that our productive land doesn't get converted into unproductive land, that is a land degradation category, with the mitigation and measurements what the UNFCC has provided, or the other agency who are working on land conservation are suggesting day by day. So under this desertification monitoring and assessment, this is a very important parameter that they have decided. Ki first you identify ki which are the categories and the areas which are under land degradation category. Because right now, if you ask, if you have not created an atlas, if what are the land degraded categories or the areas which are available on Indian map. So for that you need a satellite image, because many of the places you cannot go. So you need a satellite image because you have got various kinds of land degradation categories depending on its geographical location. If you go in Madhya Pradesh, you will be finding gullies and ravines. If you go in Himachal, you will be finding a scrub forested. If you go in the plain areas, you'll be finding wetlands, waterlogged lands. So what you are seeing is ki depending on the geographical location, the land degradation categories change. So first responsibility for any country is first to identify the categories, the areas which are available in their state, their district, their block, their village. First you identify it, then only you can have some mitigation and some planning so that that land degradation category or the area can be converted into a productive land, and that can be done only if you are monitoring the deserted area continuously. So for this, Space Application Center has been identified as National Nodal Organization to coordinate TP1. Means TP1 means desertification monitoring and assessment. Means first you map it, then consecutively each and every year you frame it, and you come with a conclusion ki what are the total amount of area in each and every district block that falls under this category, and what are the mitigation measures that the particular government, whether that is a state government or a central government, is taking into. And finally, we are putting our forces, our energy to convert this land degraded category to a productive land instead of an unproductive land, and that is monitored by Ministry of Environment and Forest and Climate Change. Okay, so one of the key requirement of this desertification is to inventory and monitoring of desertification and land degradation of the country using satellite data. As I already stated, because geographical area is very high and physically going to each and every place and mapping the area is not possible. And for creating an inventory is just like a directory. A directory means first to identify the area, then to plan the mitigation policy, and then to act upon. Then you have to have a action plan, and for that satellite data are the best technique for mapping this land degradation category. Indicators of desertification methodology and classification team for its monitoring using satellites have been evolved by Space Application Center. So next is, we have already seen key what are the ill impacts of desertification. Now, what are the causes of desertification? What are the causes? One is unsuitable agriculture practices. Means whatever agriculture practices that we are performing on land is unscientific. Means what are those? One is extensive and frequent cropping of agricultural land. One of the most important thing for getting your productive land to unproductive land or is being converted, because we are irrigating, because the demand is very high, the population is very high, we want to have more money at our home, economical stability, each and everyone wants it its life. So what we are doing, we are going on doing cropping in each and every portion of the land. So if you go around your area, you'll find that each and every, there is no season left out, so that the soil takes a rest just like a human being. If you go on working throughout day and night, how many day you can be asleep? You have to be, you will be tired enough. In the same way, if you are going on cropping on any agricultural land without any gap, without any proper recommendation, the soil also wants to breathe, the soil also wants to take rest. But we the human beings, because of our human weights, we are going on cultivation without seeing that we are making this soil, the land which is a productive, into a unproductive land, because of the excessive use of the fertilizers. Means we are going on putting more of fertilizers into our agricultural field, which is degrading the quality of soil in that area, because we think that if we put more fertilizer, the cost of or the productiveness of the product will be high, and there will be huge amount of benefit after selling the product. But that is degrading the quality of land. Nobody sees to that, because money is involved into it. Then shifting cultivation without allowing adequate period of recovery. Like if you are ill from corona also, so anybody says that post corona or COVID-19, at least you have to take 15 days and you have to see yourself, see what is the pattern, how you are feeling, and take rest. In the same way, even if you want to give rest to your agricultural field, the number of days that is required is not accurate or not adequate, because we do as per our needs. That if for a particular soil, the 1 month of recovery is the, we do give only 10 days. So what is the minimum time that is required is not up to much. So the land is getting itself converted into unproductive land. Then unsuitable water management means proper and inefficient irrigation practices. So you're seeing that the monsoon periods are only restricted to 4 months, that is July to October maximum. And if you are not managing the water, the next cropping patterns for the other season area will be very poorer in condition, and many times you don't have water for plant productivity, and that will gradually degrade the quality of land. So that is over abstraction of groundwater. So in order to maintain or sustain our demands of the water during the non-monsoon period, we go on extracting the subsurface water, that is underground water. We go on extracting and extracting, and that is also degrading the, or it's a reason or a cause of land degradation. Then the other most popular, right from our childhood, we are knowing about deforestation. So we are cutting down the trees without proper strategy. So that's why unsuitable forest management practices. Like if I ask today, ki how much of you or in your family have planted a tree, the answer will be nearly, I'll ask, most of you will say no. But if you see the amount of product that we are using related to wood in our houses, that is the furnitures, the doors, the tables, we are cutting down the trees and we are planting nothing. Maximum planting, what we are doing, we are flowering it at our garden and we're saying we are planting a tree. That cannot be a substitute to a tree. So you have to see that ki how the forest land clearance is being done for agriculture, because you'll see that the production population all is increasing. So where from this population, if they are increasing, if you will see, if previously, like I had only one home at Ranchi, but if I see that over the period of time, as the my brothers go old, I have grown old, we have got various houses at various locations. So at last, what we are doing, we are taking the good or productive land for construction of houses. And where that construction of houses land came up, that land came up either through agricultural land or by cutting down the tree. And in both the cases, we are damaging the earth. So other land uses for which we are doing the cutting, like we want a very clear road, unstable road. Like if you go to Himalayas, especially to Shimla, Manali, you will get 4-lane road being constructed along this Himalayan terrain. This is a tectonic plate area, and such kind of activities or construction should be prohibited, so that the natural ecosystem, the natural uh, features doesn't get harmed or get deteriorated. Because we are making it, we are using it for various kinds of construction, like waterways, roadways, dams. So what we are doing, we are just unstabling the entire ecosystem, especially in the areas which are tectonically active. So recently you have seen ki how Kedarnath flood, or in Uttarakhand flood, there was a flash flood where the entire dam was down. So that is what, that is a response or a feature, that is the nature is suggesting ki please stop your influences, keep your needs to limit. But we the human being are always thinking, always in a hunger mode. So that creates a overgrazing, excessive full wood collections, and uncontrolled logging, illegal felling, and forest fire. All the forests are being cutted down for our day-to-day activities or for our daily needs, and at last this will result to a poor management of land. Thereafter, transformation of land for other uses, like we are using the forest land to agricultural land to some other houses, construction, factory setup. So, such kind of encouragement of cities and towns into the agricultural land. So, you will see many of the cities or all the cities of India, major city, If you see in 1970, there was a small city in the periphery of the city, and adjoining that, there were a lot of cultivation and agriculture is being done. But after 50 to 60 years, you'll see the city has expanded, and the entire agricultural land has gradually converted into this constructed land, whether that is private houses or commercial houses or single building, whatever kinds of construction you are saying. So where that land came up because the agricultural land was converted into desert, means constructions. Then industrialization, mining, and other activity without satisfactory measurements for preservation of land degradation and land rehabilitation. So what we do, we go on doing our industrial activity. We go on mining, coal mining is there. Then you have got various kinds of other iron ore mining is there. Then you have got stone mining is there. So government has formulated some rules and regulation. These are the standard measures of practice that any company has to be performed or is will be performing in that area. But because of to get more benefit, have more profit, the companies generally don't follow the rules and regulation prescribed by the government of India, and that in general is making the entire area where we are going for any kinds of bricklaying industry. If you take in plain area or you take mining industries, that is making the land infertile. And finally demographic pressure of both the human being and livestock are creating frequent droughts, frequent floods, frequent earthquakes, frequent landslides, frequent avalanches, and all these parameter, all these terms are related to the term that is known as climate change. So you have to have a eye on the entire operation. So now we'll see what are the various kinds of land degradation categories that is being mapped by Space Application Center using the help of satellite remote sensing the satellite data. So we'll start up the vegetal degradation means vegetation loss. So vegetal degradation, loss of vegetal cover, mainly observed as, so with this vegetation cover is getting decreased, the soil means the forest is getting decreased, squeezed up. Why it is? Because of deforestation. That is the most important thing, that for our personal way we are going on cutting the trees without having a proper replantation or afforestation plan, that is creating an imbalance in the entire ecosystem. Thereafter, forest land, silting cultivation, and degradation in grazing and grassland is scrublands. So you can see how this scrubland will be identified in a satellite images, and how the same field will be represented or is shown in the ground. So whenever you are talking about remote sensing, we are talking about satellite data. But whenever we are talking about satellite data, the credibility of the data has to be verified by going into the field. So whenever you want to go into the field, you have to first identify the area. So we have identified the area as yellow in color, and then we have gone into the field. We'll be taking the GPS coordinate of that area, and we'll be geotagging the GPS field data to our satellite data, so that we can provide the field photograph of the area, the GPS location of the area, and certifying the findings. Because many of the persons can say whatever understanding or whatever feature that you're stating, I am not agreeing to it. Maybe this is a very good forest type, but because there has been leaf shedding, and that is giving a reflectance of a scrub land, I don't agree to the classification or the mapping that you have done. So, in order to prove your results, in order to have a strength to the answers what you have mapped using satellite image, field data is compulsory, because you have to justify your findings. So if I am correct at any particular place and I have taken up that samples of 4 to 5 different places of the same category, and I've got a GPS location of all these 5 categories, and I find that the mapping category or the classification accuracy for my map was more than 90 to 95%, I'll presume that wherever I have mapped that particular class or any other class, I'll be taking some sample slides, I'll be taking the photographs in order to justify my results. So at places, agriculture is often observed within the forest land. You can see कि either it can be a deep forest land, or there can be some agricultural activity going in and around the forest land, and this has been classified under vegetation degradation within forest area. So many times you will be finding some agriculture going on within the protected area or the protected forest, and such area will be seen using satellite images and the field photography. So you can see a vegetation degradation inside a forest as visible in advanced field fight sensor image covering parts of Meghalaya with corresponding field photograph. So what we are saying, if you see this kind of reflectance, it is not that always will be classifying that into a scrubland, but if you are making any agriculture inside the notified forest area, that and you're degrading the quality of the forest in that area, so that land or that category or that parcel of land that you have digitized to will be classified as vegetation degradation. Now next, vegetation degradation we have seen that are more particular in the hilly terrains or the mountainous terrains or in the protected area, protected forest. Next is water erosion. You'll be finding many of the features that are created on the land on the basis of forest. So water erosion is a loss of soil cover. So what happens when there is a lot of water coming up, water erosion takes place. So you will have a loss of soil cover that is due to high rainfall or surface runoff water. As we are already studying how you have to protect our runoff, how you will be conserving your runoff using drainage morphometric analysis. Then you have to have a water budgeting so that the loss to the soil, the productive soil, is not deteriorated and it doesn't takes away with him or her the productive soil. So water erosion is observed both in hot and cold desert area. So such kind of erosion is very popular in whether you go for desertic terrain you or whether you go for a cold terrain across land covers with varying severity levels. So such kind of water erosion features will be created anywhere depending on its location. First one is splash and sheet erosion. That is the activity that directly based on the movement of soil by splashing, means cutting off that topsoil. Soil particles can be thrown as far as 3 feet by raindrop splash. Means raindrop, if it goes, it can go up to this many way. That is the removal of thin layer of soil from a large area. So if a thin layer of soil goes away with water, that will be classified as sheet, just like a sheet in a plane, and that is the topsoil. Next is real erosion. What is real erosion? Real erosion is a series of small channels on a slope carved by running water. So you will find that there is a slope and there is a water coming up. It will go on degrading it and it will create as a, you can see in the satellite images as well as in the field photograph how this reels or the gullies will be seen on the field. Then you have got gully erosion ravines, large white channels carved by running water. So you can see this gully ravines, how this gully ravines will be seen in the satellite images and how it will be seen on the ground. So you can see that gully erosion as visible in advanced wide field sensor image, that is a satellite image covering parts of Rajasthan with corresponding field photograph. So you can see that how this features are seen. So such kind of signature wherever you are seeing can be stated that they are representative of gullies. So you have to go into the field, you have to verify. So such kind of things. So you can see that in this yellow feature, how it is seen in the field. So if you see such kind of land being in the field, you can say they are the gullies and they are because of the water erosion. Then comes wind erosion. First you have got forest erosion, means agriculture vegetation erosion, then water erosion. Next come is wind erosion. This is most popular in the areas where we are situated right now. Your campus is situated right now. So wind erosion pertain to aeolian activity. So whatever erosion that is being done where wind is a factor for producing it, for performing it, that is known as aeolian activity. It denotes the spread of sand by various processes. The spread of sand, because if you go into the deserts, that is a sand. So that is a spread of sand by various processes even up to the low altitude of the Himalayas. Wind can erode the soil very selectively and intensively. So this wind we can erode the soil intensively and selectively in three transportation method. There are three method through which this wind can degrade the quality of the land, that is suspension, saltation and soil creep. So we must be knowing what do you mean by suspension. So suspension means fine particles less than 0.1 mm in size are moved parallel to the surface and upwards into the atmosphere by strong winds. Suspended particles can travel hundred of miles. So this is a regular feature that we see, that all the area near the campus many times you'll see strong winds will all the dusty materials, you'll be finding sand carrying winds. So such kind of operation where the fine material is being transported upwards towards the sky to thousands of kilometers by strong winds, such operations are known as suspension. Then second operation is saltation, where it get deposited, means movement of particle by a series of southbounds along the surface of the ground and dislodging additional particle with each impact. Means movement of the particle along the surface to few feet or few meters, as well as degrading or deteriorating or breaking into smaller fine particles within 30 meter of the surface. So that things are known as saltation. And lastly, soil creep. So what do you mean by soil creep? Soil creep means the rolling and sliding of larger soil particles along the ground portion. So here in soil creep there will be sliding. There is no movement of the ground. In the first we have movement for thousands of kilometers upwards, and in saltation few centimeters away it will be falling down, it will be breaking up, and in rolling and in this creep it will be rolling up, sliding of large soil particles along the ground surface. The movement of these particles is added by the bouncing effect of siltation particles described above. Means it will bounce up, and soil creep can move particles ranging from zero point 0.5 to 1 millimeter. So you can see these sand dunes. We are always seeing this such kind of satellite images. We are doing various kinds of our image processing exercise as well as the mapping of various geomorphological activity we have done. So you can see that this dunes as visible in advanced field sensor image covering parts of Rajasthan with corresponding field photograph. So if you see such kinds of reflection, appearance, visually, tone, texture, shape, size, you can see that we are seeing an area or deserted area. And this kind of features, patterns are denoted as sand dunes. Next one is waterlogging, most common feature in Indo-Gangetic Plain. So you are seeing that according to the terrain, according to your geographical location, you are witnesses or witnessing various kinds of land degraded category. Next is waterlogging. So what does waterlogging means? Means the undrained land parcels tend to accumulate the standing water for long duration of time on the surface. This condition is called waterlogging, especially in low-lying areas even with shallow water table. Means what happens that in each and every year there is flood being done in Brahmaputra, through Ganga, through various other systems, especially in Ghagra, Kosi, Kamla Banan, then Mahananda River, Mahanadi. So these are the rivers that are being frequently flooded in the plainland areas. So because that area is having very low slope or topography, there is no moving back of the water towards its origination place because the topography, the height is very high where from the water is coming. So because there is no external drainage system where the water moves away towards the outer periphery, the water tends to stay back at the area where it has got flooded. So what will happen? The area will be flooded, and thereafter some of the water will return back to its over position. Some will go to space or atmosphere through evapotranspiration, but many of the portion of the parcel of the land is still filled with water, and it will go with time. And such kind of features, if you go into the Indo-Gangetic plains, are very common because of their topography, soil. Maybe the area is having a high water table or the area is having clayey soil, as well as slope is zero, that results in low lying area, and the water stays in that area, creating the and degrading the quality of soil and water in that area. The severity of the waterlogging is described based on the period of the time the water is stagnant. Means if the water is flooding is there, if it go back within 2 days, and there will be only loss of damage to the land, the croppings. But if the water stays in that area, it creates or deteriorates the quality of the land. Several situations can be responsible for the rise in the water table, like generally it is because of flood. Then you have got salt rich hard pans, excessive irrigation, wrong drainage planning, water logging may lead to salinization. So what happens? I have done my PhD on this topics, waterlogging and flood hazards, the reasons whether that is natural, man-made, anthropogenic. So we'll be discussing one day that in detail. But you will see that wherever you're finding the areas under waterlogging condition, you will be finding that the same area is being salt affected. Why? Because water contain salt in it. So what happens when the water evaporates gradually over the period of time, it get deposited the salt content in that particular area or in that particular soil. And if that process is recurrent in that particular region or the specific location, the gradually the salt content in the soil will increase, gradually the productivity of the land will decrease, and one day the entire area will be converted into a salt affected soils or salt affected land. And that is most commonly happening in the areas, especially in IGNP, Indira Gandhi Nehar Pariyojana canal irrigation system, that was introduced in India with a vision and a mission to increase the productivity of land for cultivation, for agriculture, for drinking purposes in the desertificated area or desert area. but instead of making the land fertile, at many places that has deteriorated the land quality, because through those canals there is a continuous seepage, and that is creating or making the adjoining areas, the water table is increasing, and as the water table is increasing, the soil contain operation is increasing, and even if soil contain is not there, the various crops cannot be grown, because the entire subsurface soil is filled with water, that disallow or that reduces the oxygen contained in the roots, and decreases the carbon dioxide contained in the roots, gradually resulting in a very poor cultivation. So you can see that how in a satellite image you will be seeing the salt affected waterlogged areas, and the same in the field photographs in the Rajasthan. Then salinity, as I have already stated, that the soil salinity refers to the soil present in the soil. The ions usually responsible for the salinization are sodium, potassium, calcium, magnesium, chloride. Sodium predominates, soil becomes sodic. So if sodium is very high, the name will be sodic soil, sodic salinity. And if TDS is measured in milligram per liter or by electrical conductivity, at some places salinity is clearly observed on a satellite images. So salinity means where the sodium is very high, while alkalinity, there are two terms associated with salt affected land, that is salinity and other one is alkalinity. So while the alkalinization is not seen and is mostly inferred based on ground truth, soil sample analysis as well in information and published. So it's tough to identify the alkaline soil, but it's very easy to identify the salt affected land, that will be a very white and white in color. So you can see that, yeah, the salt affected land has been identified as in yellow color, and the same feature we go into the field and we map this salt affected soil. So you can see white color coming up in this salt affected land, and in around you can see some cultivation and some grasses, scrubs. So this is salinity in agricultural field as visible in advanced field satellite of Uttar Pradesh with corresponding field photograph. So you can see if you see such kind of brightness or image tone texture in your image, you directly come to a conclusion that that can be a salt affected land. And the next one is mass movement. This nowadays it is very popular, mass movement, Kedarnath. Then you have got Uttarakhand flood. So the spontaneous downwards movement of soil, either it can be soil or it can be rock under the influence of gravity, means topography slope, but without the actions of any moving fluid. There is no liquid involved into it, so that doesn't produce any kind of friction. So that is classified under the term mass movement. So generally landslide, glaciers, avalanche glaciers are mass movement activities. So the mass movement produces includes all forms of downslide, movement of the soil, overburden, bedrock under the direct influence of the gravity. Under the direct influence of the gravity means the entire mass of the land can come downward because of the overward weight, and it will go on without any kind of liquefaction, without kind of any factor. It will be because of its topographical relationship. So the mass moment represents the spontaneous yielding of earth materials when gravitational force exceed the internal strength of the material. That will create the sliding in that area, rolling, flowing of mass of soil, overburden and bedrock. So you will see that how this mass movement has been recognized or will be identified on the satellite image. You can see that along the borders, along the downwards, the entire mass movement has taken place, or there has been reducing the small kinds of soil, it can be small chips with soil particles. So such kind of movement, if it is downwards, that will be classified under mass movement category. Next is frost shattering, is just like the features that you'll be finding along the glaciers that will be classified under force shattering. So what is force shattering? Force shattering is essentially a process of mechanical weathering or background of rock. That is, you will be saying, if you have been to the Himalayas or Uttarakhand, this is more popular along the roads, you will be seeing it. And that is due to fluctuation. If you go to Leh, Ladakh, then Lal Spiti, it is very popular and common due to regular fluctuation in temperature, and because of the joints in the rock. At time of precipitation, water enters into these rocks. In winter it reaches to ice and increases in volume. This creates tremendous pressure on the surrounding rocks and generate crack. This process continues over the time, widens the joint, causes the pieces of rock to shatter from the main rock. So this broken piece of rock falls downwards and spreads over, creating a stony surface, and that is called talus or scree. And this is a regular process in periglacial environment. The alteration process of frost shattering slowly widens the joint and cracks, and times causes pieces of the rocks to shatter from the main rock. So you'll see that you will feel that the rocks, you'll find a hill of scattered plates with soil with broken. Such kind of things are known as talus, and it is more common in hilly terrain, especially in mountainous like in Lowell, Spiti, Himachal. If you're going, you'll be getting this fast scattering. So till today we'll be continuing till here. Any problem with any of the topics that we have discussed? If not, we can end the class so that you can join the other class. Okay. Any problem?
No, sir.
No,